started for page 302. Find your book, make sure they're on that page number, and let's get ready to talk about some geometry properties. I'm going to recommend that you have some tracing paper, some of that wax paper or tracing paper that we have. Have something to write with, a highlighter, maybe even like a straight edge, but definitely like, this is one of the tools you're going to need for our lesson for today. We are talking about the concept of translation, and it's related to the work that needs to happen for this lesson, proving parallel line theorems. So let's go. You may recall that you can use translations to show that the corresponding angles are congruent. There's that vocabulary word again. And if you don't have a card with corresponding angles on it, perhaps it's time. Let's go. Definition of corresponding angles. I'm going to make one for you right now. Have a note card with definition of corresponding angles. On the back, let's do a quick sketch of what corresponding angles should look like. There's a vocabulary term. The glossary in the back of the book can help you with the words. I'll use that as well later on. But a picture of corresponding angles is parallel lines cut by a transversal and then angles that open in the same side. Those are corresponding. So they deserve a highlight. Corresponding angles. Corresponding angles. In fact, I should name them. We've used numbers, so 1, 2, 3, 4, 5, angle 1 and angle 5 are corresponding angles. And I'll add more detail maybe later on, but that's it for now. So we have this concept of corresponding angles being a thing. I'm going to add one more actually as I think about it. Corresponding angles are congruent. So not only do I have angle 1 and angle 5 written down on the note card, I can even write angle 1 is congruent to angle 5. Which, by the way, one of our vocab words says definition of congruent angles. So definition of congruent angles means that if the angles are congruent, their measures are also congruent. Measure of angle 1 is equal. Oh my gosh, take out the equal sign, the congruent sign. They're equal. Little typo in the moment. You may recall that you can use translations to show that corresponding angles are congruent. So consider the parallel lines M, that's the top line, and N, that's the bottom line, with a pair of corresponding angles, angle A and angle B. Remember, a transversal is a line that intersects two or more other lines. So transversal as a vocabulary word, highlighting the transversal yellow. Corresponding angles are two non-adjacent angles. So this is what I'm going to write down. Right? Okay, that lie on the same side of the transversal. So these are both on the right side of the transversal. One angle on the outside, that would be B in this case. And one angle on the inside of the lines, that would be A in this case. Furthermore, alternate interior angles are two non-adjacent angles between the two lines and on opposite sides. So it would be like angle A, and then if I bring in an angle C right there. They're between the two lines. They're on either side of the transversal, like angle A and angle C. So examples for you to use for the information from this lesson. All right? We need to know what corresponding is. We need to know what alternate interior angles are. We need to know what a transversal is. So vocabulary, vocabulary, vocabulary. Right? Check it. Highlighted. Okay. Use patty paper to translate one of the corresponding angles so that one of the corresponding angles so that it lies on top of the other corresponding angle. Identify the line of translation and describe the distance and direction of the translation. So let's do that. Let's go ahead and take the tracing paper and trace. Let's go trace angle A. So tracing it carefully, trace and line it up. Okay, so there's angle A. And then to do the directions of this one, we're going to translate so that it lies on top of the other, which means I don't turn the paper at all. That would be a rotation. I don't flip the paper at all. That would be a reflection. I'm just going to slide the paper from where the angle A is up to angle B. I'm actually sliding this angle along the transversal. That means then that line AB is the line of translation. Right? You have to be able to describe how that action is being completed. And so in this case, sliding angle A up to angle B, we're sliding in the direction of line AB. Angle A is translated along line AB. Okay. It's translated in the direction of ray AB. So if you start from A and go this direction, you're going along an arrow. That's like a vector from, Despicable Me. Direction has both, or a vector has both direction and magnitude. We're going a certain distance. So along line AB in the direction of ray AB. And notice the use of the notation here. Ultimately, we will describe the translation this way. The translation is in the direction of AB. We are translating angle A to angle B. That's how we should notate it. All of these words notated with just a few symbols like that. A translation in the direction of ray AB. We're translating angle A, and it's going to land on top of angle B. Why is this line AB considered the line of translation? I mean, could we have translated along N or M because they're parallel? It wouldn't have moved angle A on top of angle B, though. And we want to make sure that angle A and angle B match because they're corresponding angles. So they have to be able to be, without turning the paper, slid from one spot to the next. Is angle A congruent to angle B? Just a little quick measurement. Angle A right there is about that big, and angle B, when you slide angle A on top of angle B, yeah, they are. Angle A is congruent to angle B because of translations. All right. What does the translation demonstrate about the corresponding angles? That's it right there. It demonstrates that angle A is the same size as angle B. Right? When we were able to take this angle and slide it along the translation vector, ray AB, you get the same angle in both spots. Angle A and angle B are the same size. So they must be congruent. Which angle in the diagram is congruent to angle B? Angle A. Why is that the case? Because translations preserve distance, and translations preserve how big an angle's measure is. Describe how you can use patty paper translation and what you know about vertical angles to demonstrate that alternate interior angles are congruent. Vocab word, time to highlight. Alternate interior angles are congruent. It's also worthy of a note card. Definition of alternate interior angles. Like, you should have a note card for this one as well, and we'll put some information on the back. So on the back of this one, I'm going to put the picture of parallel lines being crossed by a transversal. And so there we go. Angle 3 and angle 5 are the same. Angle 3 and angle 5 are alternate interior angles. But then this right here says that they are congruent. So I'm going to write that angle 3 is congruent to angle 5. And if angles are congruent, then their angle measures are also equal. So the measure, get that back. The measure of angle 3 equals the measure of angle 5. Those are all the things that we get from alternate interior angles. See it again. Pause the video. Let's answer question 2 and finish up the getting started. Here we go. Describe how you can use patty paper. Well, I mean, vertical angles. Oh, I should put that up here too. Alternate interior angles use vertical angles. So I want to make sure I have that moment as well, and corresponding angles. And by the way, this is on page 302. Okay, all details for the back of the note card, so I can go back and like reference the book when I need to. So vertical angles would be the angles that are across from each other. And if you notice in the diagram, I drew angle B and I added to the picture angle C. They are vertical angles. And then angle C and angle A also need to be there. So here's what I can do. I can label angle C across like vertical angle to angle B. Move my face out of the way for a minute. So I can label angle C across from or vertical to angle B. And then by doing that, I can use the patty paper to reflect, right? Actually rotate. I can rotate angle B around its vertex on top of angle C. So angle B and angle C are congruent. And we also know that angle A and angle B are congruent. So if angle A and angle B are congruent, here you could pause right there, but I'm going to go up to the diagram. If we know that angle A and angle B are congruent, and angle B and angle C are congruent by vertical angles, then it must be true that angle A is congruent to angle C. And angle A and angle C are alternate interior angles, and they are congruent. That's a little informal proof for you all as we finish out the crisscross applesauce getting started, page 302 video. Thank you for watching. I hope that you've had a chance to learn something along the way. Page 303 is next, and lesson 2 with all of its density to follow. Make sure you have your note cards. Keep adding to the pile of note cards that we are creating from this topic. Trust me, there is a lot of geometry to know. You need to keep track of it and have it ready to be used. Thank you for watching. See you on page 303, and wishing you all a very good day. Thanks. Bye.